graders, today's lesson is 1.5 chemical reactions. Your learning target for today, I can differentiate between substances and their properties. All right, so whether you guys are DLI and you're doing this at home or whether you guys are sitting in class right now doing it, that's fine. Those of you guys sitting in class right now, I want you guys to make sure your laptop is facing forward so you guys can pay attention to the next sections. All right, so your guys' bell ringer for today was to come into class and add to your OneNote. So you should have opened your OneNote, added a new section titled Chemical Reactions, and then 2 new pages titled Vocab and Key Concepts. Should look a little something like this. Here's my new section, Chemical Reactions, and then I have the 2 new pages, Vocab and Key Concepts. You guys can see vocab, I have property added already, something that can be observed about a substance such as its color, smell, or boiling point. We really dug into a lot of properties yesterday, talking about matter and then chemical and physical properties, how we identify a substance. Okay, atoms again, last week we went over a lot about atoms, the tiny pieces that all matter, all the stuff in the world is made of, and then substance is something kind of new, but it's really not an unfamiliar word to you guys. Something that is made up of the same atoms or groups of atoms. Okay, and you guys should have added the Unit 1 question, how do new substances form? That's going to be the focus, obviously, for this whole unit, talking about how we can take 2 completely different chemicals or substances and then combine them together in some way or rearrange them, where we've switched around atoms and molecules to form new substances that have completely different properties from what they had before. Okay, and then your guys' focus for today's lesson will be that different substances have different properties. All right, so that's what your guys' OneNote should look like. You guys should have also completed your warm-up on slides 3 and 4. So on slide 3, you guys see this picture, and this little white powder right here is potassium chloride. It's made of potassium and chlorine. So you guys can see from the key right here, not like it's not already labeled. That's what sample 1 looks like. Sample 2 is something that should be very familiar to you guys. It's table salt or sodium chloride. So you guys can see Na is sodium, chlorine is Cl, and you guys can see that they look very similar. So your guys' warm-up today was to use your draw tool to answer this question. Based on this information, do you think samples 1 and 2 share the same properties? So you guys would circle either yes or no and then explain your answer. All right, so now that you guys are done with your notebook and your warm-up, we're going to go ahead and move on to activity 3 together. Okay, so I'm going to show you guys this video and then show you guys how to use the scale tool, and then you guys will answer this question. So again, your guys' laptop should be facing forward if you're sitting in class right now. I'm going to go ahead and right-click and open this link for you guys, and then I'm going to play this little video for you. It's fairly short. It's only about 1.5 minutes long.
Look at this butterfly. Ever wondered what it's made of? This butterfly, this picnic table, and this water are all made of atoms. Everything is made of atoms. Atoms are too small to see. They are so small that scientists can only make images of atoms using the most powerful microscopes in the world. Still, we know everything is made of atoms. Scientists use models like these to represent atoms. If you could observe things that small with your eyes, you could look around and see that all matter is made of atoms. For example, water is made up of atoms. This model shows atoms joined together in groups called molecules. Water molecules are made of hydrogen and oxygen atoms. What about this table? It's made of wood. But what type of atoms make up wood? Wood is made up mostly of hydrogen, oxygen, and carbon atoms. Even the air we breathe is made up of atoms. Air on Earth is made up of mostly nitrogen and oxygen molecules, and those molecules are made of atoms. Now when you look at the world around you, try to remember that atoms make up everything you see, even you. You're made of atoms too. Every single thing is made up of atoms and nothing else.
All right, so we just watched that video, and now I'm going to show you guys how to use the scale tool. So you guys will open this link right here, and your goal is to find atoms in here and kind of see how small atom is compared to other things. So this is your scale tool. You guys can click and drag this little blue circle here, and you guys can go out and see the biggest thing is the observable universe. Okay, there's the Milky Way. You guys can see how large that is compared to what we think is the universe. And so on and so forth until you guys have found Adam. You guys can, little hint, see it right there. All right, so go ahead and find atoms in the scale tool and just kind of compare it to how small it is to some other things that you know. And then answer this question: why can't you see individual atoms without special tools? So at this point, you guys can go ahead and pause this video, flip your computers around, answer that question. And when you guys are done answering that question, go ahead and face your laptops back towards the front, and we can continue on to the next activity. All right, so moving on to activity 4 is your sim. You guys are gonna go ahead, right click the sim and open up this link here in a second. But I wanna show you guys where you need to go in the sim link. So it says right here, click the 3 horizontal bars in the upper left-hand corner and select chemical stock room. You guys are gonna have about 5 minutes to explore this simulation. So I'm just gonna show you, you're up here, you're gonna click chemical stock room and you're gonna click yes, I wanna load that. And then you guys can see there's all kinds of things you guys can do over here. And then you guys will grab some chemicals and see what you guys can do if you mix them. Okay, so go ahead. This would be the time to pause the video right now. Have the kids flip your guys' computers. Take about 5 minutes to explore. And once that 5 minutes is up, you guys can go ahead, flip your computers back facing front, and we'll move on to the instructions for the sim. All right, your guys' computer should be facing forward now so I can go through the instructions for you. So using the chemical stock room to compare samples. So a lot of you guys are working by yourself at your table, that's fine too. But you guys are gonna compare the atomic scale models of 3 samples shown below. So you guys can see sample 1, looks like it's got a C and then 2 O's, so that's carbon and 2 oxygens. Sample 2 is a C with 1 O. And then sample 3, we've got a C with 1 O, C with 1 O, and then you guys can see carbon and oxygen are our 2 elements that we're dealing with here. Discuss how these models are similar and how they are different. Choose the claim about the sample you think fits best. Then use the chemical reaction simulation to gather evidence about these claims. When you are ready, answer the questions below. So first you have a little prediction to make before you guys jump into the simulation. So based on the atomic scale models of the samples, which of the following claims do you think is best? So you guys will need to use your draw tool to circle your answer here. So claim 1, all 3 samples have the same properties, therefore they are the same substance. Okay, so again, you guys would need to look at that in the sim, but we're just making a prediction right now. Claim 2, 2 samples have the same properties, therefore they are the same substance. However, 1 sample has a different set of properties, therefore this sample is a different substance. And then finally, all 3 samples have different properties, therefore they are different substances. So go ahead and circle claim 1, which basically says that they're all exactly the same, all 3 of them. Claim 2 says 2 are alike, but 1 is different. And claim 3 says they're all 3 different things, okay? So go ahead and circle that, and then you can go ahead and open your sim back up, find those 3 samples, and then observe their properties, then answer these questions. So use your draw tool. Does this evidence from the sim support the claim that you chose? So again, the 3 claims were that all 3 are exactly the same, 2 are the same and 1 is different, or all 3 are different. Okay, what evidence did you find in the sim to support your answer? Use some specific evidence there. And then you guys will go on to answer these 3 questions as well. Circle which statement is correct. Sample 1 is the same substance with the same properties as sample 2. Sample 1 is a different substance with different properties than sample 2. Okay, so that's the first one for you guys. Then you guys will compare sample 1 and 3. Sample 1 is the same substance with the same properties as sample 3. Or sample 1 is the same a different substance with different properties than sample 3. So again, you're circling which of those 2 statements is correct. And then finally on the last one, you guys compare samples 2 and 3. Sample 2 is the same as sample 3, or sample 2 is different than sample 3. Okay, once you guys have slides, let's see here, 8 through 12 done, go ahead and flip your guys' computer back forward, and we're gonna go ahead and take a minute to pause this video to let you guys answer those 8 through 12 slides. All right, so you guys should have just finished slides 8 through 12. Okay, and we're gonna go ahead and move on to last activities. So first of all, I want you guys to add these to your key concepts. So you guys can go ahead, right click, copy that, and then go into your key concepts and paste this in there. So that's the first thing I want you guys to add to your notebook. And the second thing I want you guys to add is on slide 14. It's this little picture that kind of represents what we were just talking about that I'm going to go over here in a second. Okay, so we're going to add this as well. And then I'm going to go through those. So once you guys have those added, again, you can take a second to pause this video for everyone to add those. I want to go through them. So add these to your OneNote, pause this video, and then once you guys are done adding those, go ahead and flip your computers forward so we know when you're done, and then we can restart this video. All right, so you guys just added these to your OneNote. I just wanted you guys to have a little bit of notes that go over some of these concepts of how we can look at patterns of atoms and molecules and how we can kind of relate that to the different properties that atoms have. So for instance, if we have a pure substance such as gold, okay, we know that gold is an element on the periodic table. So if we have a block of pure gold in front of us, the only thing it's made out of is gold. Okay, so all of these atoms come together to form gold. If it's a solid substance like gold is, it's also called an extended structure. Basically what that means is we need a lot of atoms of gold to make up an object that we can see, like even a little fleck of gold has to be made of a lot of atoms. So that would be an extended structure. Okay, something like table salt, also going to be, so this is just repeating atoms because it's just the same substance, versus if we look at these two here, these are groups of atoms. I prefer saying repeating molecules, but you guys can see that they can arrange themselves differently. If this is a solid, it's also extended structure. This is NaCl, which is table salt, so that's an extended structure. In order for you guys to get one little grain of table salt, you guys need a lot of molecules of sodium chloride, or NaCl. Okay, so those all form together like we know solids do, where those molecules are all really compact and close together to be a solid. So that would be an extended structure, as we know salt is, again, a solid. Okay, versus water is a bunch of water molecules, but they don't form one object. Okay, they can be separated pretty easy. They kind of move freely past each other, so they're not hooked together in any specific way like salt is. Okay, again, salt wouldn't be a solid if all those molecules of NaCl weren't kind of attached to each other in some way. So water, again, and air as well have different properties. So these are repeating groups of atoms or molecules, however you guys want to look at it. But something that's solid is an extended structure versus something that's kind of independent. We could take a couple water molecules and separate them from more molecules. That would be just a group of molecules. Okay, so again, repeating atoms, substances like gold are made of the same atoms that repeat. If we're looking at, for instance, a diamond or graphite, those are both made out of pure carbon. So that would be an extended structure because they're both solids, but repeating atoms. Okay, repeating groups of atoms, substances such as table salt and water are made of groups of atoms that repeat. So we're basically looking at molecules there. In substances such as water or cellulose, these repeating groups of atoms form individual molecules, each of which is a separate group of atoms. So this is a separate molecule than the rest of the, like salt, for instance, kind of makes one big conglomerate. Okay, molecules can range in size from 2 atoms to thousands of atoms. Substances made of molecules can be found in solid, liquid, or gas phase. Then finally, extended structures are typically solids, where they have many atoms or molecules repeating themselves to form extended structures. These can also be called crystals, golden table salt, or examples. Okay, so there's your guys' examples for that today. So let's kind of review back to what we did in the simulation then. Okay, in the simulation you guys saw sample 1, sample 2, and sample 3. Sample 1 is carbon dioxide. It has carbon and 2 oxygens. Versus sample 2 is carbon monoxide. Okay, both very different. Carbon monoxide can kill you versus carbon dioxide is something that we produce naturally in our body when we go through cellular respiration. Okay, so these are definitely two different substances, although they're kind of made out of both carbon and oxygen. They're made out of different numbers of oxygen, and that makes them very different in their properties. Okay, same substance, however, are samples 2 and 3. So this is the difference between us having just one molecule of carbon monoxide and having many molecules of carbon dioxide, or excuse me, monoxide. So sample 1, carbon dioxide, has a different substance and different properties than sample 2, carbon monoxide, because they are made up of different repeating atom groups, i.e. each molecule has a different number of oxygen atoms, so 2 and then 1. Versus sample 2, carbon monoxide is the same substance and has the same properties as sample 3. So whether we have one molecule or we have many molecules of carbon monoxide, they're all going to have the same properties because in both models, it is the same group of atoms that repeat. So we have the same numbers of carbon and oxygen, or the same ratios no matter how many molecules we have. All right. So you guys can go ahead and we're going to move on to slide 7. So your guys' computer should still be facing the front. While you listen, I'm going to go through the last activity of the day, which is the modeling. And then you guys will have the rest of class to finish, well, not the rest of class, but the next couple minutes to finishing up the modeling activity. And then after that, you guys will watch a little video, okay? If you guys are DLI, you don't have to worry about that video for today. This is the end of your lesson for today. All right, so activity 7 is our final activity for today, and it is modeling. So here's your premise of your modeling tool. In her lab, Dr. Young has 2 samples that are both made up of hydrogen and carbon. Okay, the last example that we just looked at with the pictures, we had carbon and oxygen. So this one is going to be hydrogen and carbon instead. Some of the properties of each sample are listed below. A model of the group of atoms that repeat to make up sample 1 is shown below. So we just are looking at one molecule. Use the modeling tool, 2 samples at the atomic scale student sheet to create a model that represents a repeating group of atoms that could make up sample 2. Follow the instructions below. So you guys will see that on slide 17, which is our next slide. Your goal is to create a model that represents a repeating group of atoms that could make up sample 2. So remember that Dr. Young had 2 samples. Both were made up of carbon and hydrogen. You guys are going to see what sample looks like here. Sample 1 looks like here in a second. But you guys are going to be responsible for creating sample 2, which we know is different than sample 1, but is still made up of only carbon and hydrogen. Okay, so for sample 2, draw a possible atomic scale model. Again, I'll show you that in a second. And then your optional is to either color the key. So I'll go over that. And then tips, refer to the properties of each sample provided. There is more than one possible answer. Okay, so sample 1 made of hydrogen and carbon, smells odorless, boils at negative 164 degrees Celsius. So we know it's a gas at room temperature because room temperature is way warmer than that. Looks like a colorless gas. So this is what this looks like. This is actually methane gas right here. So it has 1 carbon in the middle and then 4 hydrogens around the outside. Okay, we know sample 2 is different because even though it's made out of carbon and hydrogen, it's similar to gasoline, and we all know gasoline has an odor, whereas this sample 1 is odorless. Okay, it boils at 36 degrees Celsius, so that means it's a liquid at room temperature. Remember, room temperature is between 20 and 25 degrees Celsius. So it hasn't boiled and turned into a gas yet. It is a liquid at room temperature, and it looks like a colorless, and again, it says liquid right there. So you guys are going to use carbon and hydrogen to build a molecule of some sort that's different than this methane molecule here. Okay, you guys have 2 options on how you do this. You guys can either click and drag your carbon and your hydrogens over here, choose as many as you want. There's some limited supplies, but you guys can do that. Otherwise, you guys can use the color in the model and use white and black to kind of draw out your molecules. So 2 options there, either use your draw tool or you can click and drag the hydrogens and the carbons. So go ahead. You guys can flip your computers around now, build a model of a molecule that's different than this, but still made out of only carbon and hydrogen that would have different properties, okay? Once you guys are done with that, go ahead and complete your wrap-up, and then you can turn this assignment in, and for the rest of the class, you guys will be watching a video. I hope you guys are having a great day, and I'll talk to you soon. Thanks. Bye.